Hi guys, today I'm bringing you a brief presentation about the trigonometry course. First of all, the person who speaks to you is Gustavo Chiara, a mechanical electrical engineering from Lima, Peru, in the National Engineering University. Starting with the presentation, I'll talk to you today about angle measurement systems. This topic is very important for all engineers, architects, because on a daily basis, they are basic notation that are used on the field. Uh, well, First of all, in the first part, I'm talk to you about introduction, and I talk about the definition of the trigonometric angle, which is a trigonometric angle, sign convention for the trigonometric angle. So it means if the angle has a negative or positive measure. And finally, the system of measuring angles that actually use are three different systems that we are talking in the next slide. The trigonometric angle definition. It's the angle generated by the rotation of a ray around a fixed point called vertex from an initial position, initial side in the picture. For example, the ray which has the name of A, and to end position inside that has a that has another A. In the picture we can see the vertex, that it's the fixed point. Ray OA is the initial side, the other is the end side, and the angle is the measure of the trigonometric angle. Convention. First of all, clockwise. So it means that when the ray rotates clockwise, angles of negative measures are generated. From the other side, counterclockwise, when the ray rotates counterclockwise, angles of positive measures are generated. That's in the picture. In this part is very important the following note. The magnitude of the measure assumes any real value, and when the ray rotates counterclockwise and it consists in the first time with the starting side, it's called the angle of a turn or a revolution. Systems of measuring angles. The first system that I'm talking about is sexagesimal system or English systems. It's systems whose fundamental unit of measurement is sexagesimal degree, which is defined as a 36 parts of the angle of a turn. That is that the measure of one turn divided by 360 is equal a 1 sexagesimal degree. So the measure of one turn is equal 360 sexagesimal degree. In these systems you have the sexagesimal minute and the second and the sexagesimal second. So it means that 1 degree is equal to 60 minutes. 1 minute is equal to 60 seconds, and 1 degree is equal to 3600 seconds. The other system of measurement angles is the centesimal system, that is the French systems. In these systems, whose fundamental unit of measurement is a centesimal degree, which is defined as the 400th part of the angle of a turn. So it means that the measure of one turn divided by 400 is equal to 1 centesimal degree. So the measure of one turn is equal to 400 centesimal degree. In these systems, you have the centesimal minute and the centesimal second. So 1 centesimal degree is equal to 100 minutes. 1 minute is equally 100 seconds, and so 1 centesimal degree is equal to 10,000 seconds, centesimal second. Finally, the last system of measurement is the circular system. It's the system whose fundamental unit of measurement is a radian, which is defined as the measure of the central angle that it determines in the circumference, an arc of equal length of the radius of the circumference. So it means that we can see in the picture a circumference with radio r, and so an arc that has the same magnitude. So the angle that is formed has the measure of 1 radian. It means that the measure of one turn is equivalent to 2p radian. And remember that the value of p is about 3.141593 approximately. So it means that 1 radian is equivalent to 57 degrees 17 minutes 44.8 seconds in the centesimal degree, in the sexagesimal system, sorry. And well, in the other system, the centesimal system, so 1 radian is equivalent to 63 degrees 60 minutes 19.8 seconds. The main part about this topic is the relationship between the unit. That is very useful when we are going to resolve any kind of problem about this topic. So we know it, that the measure of one turn is equivalent 360 sexagesimal degree, equivalent to 400 centesimal degree, so equivalent to 2p radian. Simplifying, 180 degree sexagesimal is equivalent to 200 centesimal degree, equivalent to p radian. Also, simplify, we have we find that 9 degree is equivalent to 10 centesimal degree, sorry. And so in analyzing, we know that 1 radian is bigger than 1 degree, bigger than 1 centesimal degree. So this both expressions is the same, because you need to reduce in order to find this expression. So in the other slide we are going to talk about how to resolve any kind of problems. We are going to resolve 4 problems, and so if you want, just give me a message, and I can resolve any problem about this topic or another. Thank you. Problem number 1. According to the figure showing, what is the equation that relates to the angles alpha, beta, and theta? So we need to know what is the relation between these angles. Well, first of all, we need to remember that the convention of the sign in this kind of trigonometric angle. So in that case, for example, in the first point, the convention in this case is has another convention, so we need to all the angles need to know the same convention in order to find the relationship between us. Well, so this is the expression. So remember that a turn is equivalent to 360 degrees and equal to the other side. Well, remember that inside a triangle the summatory of the angles is equal to 180 degrees, and well, we need to plus 360 plus alpha minus beta minus 360 plus theta. This is equal to 180. So simplify that we need finally have the solution of this problem. Alpha minus beta plus theta is equal to 118. So the answer is the letter A. Problem number 2. According to the picture showing, calculate x plus 118. So in that case, when we have a different systems, for example, sexagesimal system and centesimal system. So we need to convert in one system in order to plus the expressions or minus the expression. Well, okay. Negative theta minus x minus theta in a sexagesimal system is equal to 180 sexagesimal degree. So we need to simplify this expression that is the same, and we have that as 8 sexagesimal degree is equivalent to 10 centesimal degree. So in that case we have all the expression in the same system. So minus theta minus 9 theta divided by 10 minus x is equal to 118. Well, we need to move the expression x to the other side in order to have x plus 118. So in that case the answer of this expression is minus 19 theta divided by 10. So is the letter C. Next to the other slide. Problem number 3. According to the picture showing, calculate beta divided by alpha. Well, in that case we have the same systems but in different categories, so at degree, minutes and second. Well, from the picture we have that alpha second plus alpha minute is equal to beta sexagesimal degree. So to convert everything as a sexagesimal second, so remember that 1 minute is equivalent to 60 seconds, and well, and a 1 degree is equivalent to 3060 seconds. Well, alpha plus 60 alpha is equal to 61 alpha, equivalent to 3600 beta. And so we need to divide alpha from the other side and have the expression that beta divided by alpha is equal to 61 divided by 3600. So the answer is the letter A. Problem number 4. If 5 minutes in the centesimal degree is equivalent to x minute y second in a sexagesimal degree, calculate x plus y. Well, we need to remember that the equivalent between sexagesimal and centesimal degree. So 180 sexagesimal degree is equivalent to 200 centesimal degree. Well, simplify, we know that 9 degree is equivalent to 10 in centesimal degree. Well, we need to get the expression of 5 minutes. Well, a degree is equivalent to 60 minutes, and a degree in the centesimal system is 100 minutes. Well, multiply and divided, we have that 1 minute is equivalent to 54 minutes divided by 100 in a other system. Well, multiply by reduce the expression, we have that 1 minute centesimal degree is equivalent to 27 divided by 50. Well, multiply by 5, we have that 5 minutes is equivalent to 27 divided by 10. Well, reduce the expression, we have that 2 minutes plus 7 minutes divided by 10 is equal to 5 minutes. Well, using the other expression that 1 minute is equivalent to 60 seconds, we have that 5 minutes centesimal is equivalent to 2 minutes plus 42 seconds in a centesimal degree. So that we have the expression, and well, we need to the relationship about x and a is that x is equal to 2 and y is equal to 42. Well, x plus y is equivalent to 44, and so the answer is the letter C. Well, that's all for this. Don't forget to like the video and subscribe to the channel, and don't remember that if you have any kind of problem, just give me a message and I'm going to resolve for you and upload another video for that. Thank you so much.